The SoRo Rover team has submitted an application into the 2018 University Rover Challenge to compete for our second year in a row. Seeing an exciting team growth this year, the Rover team has had on average 25 to 30 students actively involved across all subsystems. The team this year represents over 10 majors, including most engineering and several science disciplines. Since August 2017, the team has been evaluating last year's design, developing solutions, prototyping, and testing. We are pleased with our progress thus far and feel several problem points from last year have already been addressed. An overall design focus for the team this year was put in place to combat a reoccurring issue we fell into last year, the serviceability of subsystems. With a much lower percentage of welds, the entire 2018 Rover will be much easier to perform maintenance and repairs on, preventing the team from permanently losing any necessary subsystems. This year, the Rover was designed with a 30% reduction in size from the 2017 Rover. The larger size of last year's Rover increased the weight, along with creating some difficulties turning, while not providing much increase in driving performance. The 30% smaller 2018 Rover is still larger than the original 2016 SoRo Rover, which itself still had great maneuverability over fairly large obstacles. The frame of the Rover is also getting a reduction in the joint angles, along with implementing a brake system. These two efforts combined should reduce the motion where the middle wheels lifted off of the ground and caused a folding of the Rover at the middle joint. The wheel design has also changed quite a bit this year. Along with just a smaller overall wheel, the primary contact portion of the wheel has been reduced even more to allow easier skid steering. And a new rubber grouser design is being utilized this year to increase traction. Simplicity was priority when designing the manipulation package this year. We opted for linear actuators in our design for stability, rather than a chain-driven arm like last year. The range of motion restrictions that the linear actuators result in will be combated with the natural mobility of the Rover, being able to position the arm in the orientation it needs to be, along with the 2 degrees of rotation that the bevel gear wrist joint will provide. The simple U-shape claw design also allows the fine manipulation needed to grip handles, flip switches, and press buttons, while maintaining our design focus of serviceability and simplicity. The computer science team has had a great advantage this year that we didn't have last year, and that's a Rover to test communications and other software functions early on while waiting on the new Rover to be complete. Using last year's Rover as a test platform for computer science, we have already been able to showcase successful untethered communication, tennis ball tracking, calibration of the 6-wheel body with the control system, and autonomous traversal is in development now with a platform that is readily accessible to test with. The science package has seen good progress so far. The drill and vacuum mechanism has been constructed and tested, both independently and mounted on a driving Rover, both resulting in successful sample collections. At the time of this video, the soil, moisture, and temperature sensors are being added and tested. Once the required functions of the science package are complete and refined, a gas sensor array will be added to provide mission control with additional readings to further inform the science analysis team. The SoRo Rover team has enjoyed participating in the University Rover Challenge so far and eagerly hopes for the chance to compete again this summer.